Welcome to this afternoon's American Security Project webinar. This is an on-the-record conversation that will be available for attribution. A recording of this conversation will be posted on our website. All audience members will be muted during the discussion, but please use the Q&A box at the bottom of your screen to ask any questions to the panelists. With that, Jessica, over to you.
Good afternoon, everyone, and thank you for joining us today for our fifth installment of the Innovating Out of the Climate Crisis program focused on hard-to-abate sectors. Today, we have with us two really great panelists to talk about all things hard to abate. Dr. Ed Ryder from the Center for Clean Energy Innovation at the Information Technology and Innovation Foundation, and Mr. Jeremy Harrell, Chief Strategy Officer at ClearPath. Gentlemen, thank you for joining us today. And as usual, we have a very short amount of time and a lot of ground to cover, so I will jump right in and weave in questions as I can. So, hard to abate sectors. What exactly are hard to abate sectors, as the name might imply? These are hard. Why are they lumped together? And what can you tell us about why they're so hard to abate carbon emissions from?
I'll start on that by expressing the fact that many of the hard to abate industries have carbon as an integral part of their processes. They're energy intensive, but they face fierce competition. They've been around for some time, they're mature industries, and their products are intertwined with complex supply chains. So making changes are rather difficult. Decarbonization then will be expensive for those industries, technically challenging and somewhat slow. So typical industries in that space are iron and steel, cement, chemicals, refineries, and pulp and paper.
What is the difference between process emissions and those generated for heat and energy? What's the relevance of that distinction, and how does that make the process more difficult to decarbonize?
Well, process emissions, Jessica, are tied with the process themselves. So what that means is that CO2 is directly part of the chemistry that's involved in transforming those materials. For example, if we look in the cement area, limestone, which is calcium carbonate, is converted to lime, which is calcium oxide. And the difference there is a CO2 molecule. So the CO2 molecule comes off and is emitted. That's directly then related to the process chemistry. Whereas energy-related emissions are related to the burning of the fuels to produce heat, to transform materials, to accelerate reactions, and they account typically for more than 50% of the on-site energy use. So industrial heat, just to give you a scale factor there, accounts for 10% of global CO2 emissions. And to put that in reference, all the cars in the world account for 6% of CO2, and all the planes in the world account for another 2%. So in other words, process heat emissions accounts for more than all the planes and the car emissions in the world.
Wow. Jeremy?
Yeah, another thing I'll add kind of on both of those notes, and it really gets at your question about it being hard to abate and some of the solutions that Ed is discussing about here is the marriage between development and taking climate action and reducing emissions. And so it's at least a ClearPath thesis that it's probably unlikely, especially as we look at dealing with global climate change, that we're going to be successful if we're not able to de-link climate action and development. I think it's unreasonable for us to expect the developing world to make sacrifices that, frankly, the developed world that we here in the United States are benefiting from and enjoying take those type of actions. And so I think it's really critical that we focus in these areas and in these industries, because they're essential to the decoupling of development and climate action. We need to find a way to either deal with emissions in these type of processes, or ultimately make these type of products differently that enable global economic development and to tackle global emissions reductions.
I think that's fair. The things that we're talking about, these hard to abate sectors like steel, cement, these are what we use to build infrastructure. And there's been a lot of activity at the federal level to try to get ahead of that, both for economic purposes, for job development purposes, and for climate purposes. So with the Inflation Reduction Act and the bipartisan infrastructure law providing additional funding, what do you think that's going to do to help move the ball along?
I think this is a really exciting moment, and particularly in this space. And over the last 5 years, I think way more attention to American supply chains, heavy industry decarbonization, and the way that we can type to tackle these structures. And frankly, as we look towards industry or heavy industry decarbonization, this is really the first time we've seen this influx of policies targeting it from a climate perspective. And so when you think about the Energy Act of 2020, a big authorizing initiative that was bipartisan enacted roughly 5 years ago, the infrastructure bill enacted last Congress, the CHIPS and Science bill, so what was really a semiconductor focused drive originally, but ultimately became more broadly and had actually a lot of steel decarbonization policy, and then the Inflation Reduction Act. We've seen the federal support for RD&D, demonstration of new technologies, and implementing some initial incentives in place that will allow us to start to commercially scale solutions like carbon capture or innovative processes to produce steel, the production of low carbon feedstocks like hydrogen, for example, that frankly will be absolutely essential to tackling industrial emissions. And so I think really as we look over the next decade, it's how do we maximize the impact of those policies to both bring these technologies to the commercial marketplace here in the US, and ultimately with the hope of bringing these technologies to the world. Because as I was mentioning, I think it's the US's role in global climate action to help provide low cost options to the world in addressing climate that also enables growth and economic prosperity.
So I would just add to that I think you pointed out, well, Jeremy, that it's a time and an opportunity of transformation, not just in the US, but for these technologies to cascade to other parts of the world as well. A key part of that is lowering the cost of those type of technologies, but also implementing them at scale. And that's indeed a challenge, and implementing those at scale in a really compressed time frame as well.
I want to put a pin in that just for a second because I want to come back to that. But let's talk a little bit more about the trade-offs that I think are going to have to occur, right? Are there trade-offs between emissions reduction efforts and development that Jeremy alluded to, especially in these developing countries? I mean, whether it's Kentucky or Kinshasa, I mean, there's going to have to be a really straightforward way to do this, or is there going to be a lot of compromises that have to be made?
Yeah, I'll start on that. Jeremy, you can chime in there. One of the things we've seen in the last couple decades is a decoupling of the emissions versus production. So in the US, for example, from 2005 to 2017, the CO2 emissions went down in 41 states in the US at the same time that the production went up. So that shows that it is possible to decouple fossil fuel emissions from production. And it's not necessarily the case then for developing countries either, that they have to sacrifice their growth potential for their ability to cut emissions. It's not just the US that has done this, but Europe and others have done it. And that's a key part of the low carbon technologies, as Jeremy mentioned, supported there by the acts that he had mentioned, that allow us to further decouple emissions from production.
The only thing I would add there, Jessica, is that is the nut we're trying to crack here ultimately, and what I think ultimately, Congress and federal policymakers were looking to incentivize with this influx of policy that's gotten done over the last 5 years. There can't be a trade-off on functionality and lifespan. I think that's a really tough key to a nut to crack, which is why I think as we think of future policy, whether it's thinking about building standards, thinking about incentives for market events, things along those lines, it should be about performance. We should be incentivizing materials that can meet certain specs that are necessary for solid construction, and less about the technology as a whole. We want to provide a target a goal to be hitting that ultimately allows us to drive the development of solutions, low carbon materials that can meet these obligations. And then, ultimately, I think these incentives are in place to try to help with cost related issues, but that's what this decade is ahead of us. We're going to try to ensure that these solutions are also cost competitive, so that it increases the likelihood of uptick in deployment.
Sure. So let's get into a little bit more of the nitty gritty here. Let's start with concrete and cement. What are the differences there, and what are the main sources of emissions, and what are the technological developments that you're seeing in those industries? Either one of you?
Well, I'll let Jeremy go first on cement, because I know they've been doing some recent research in that space.
Yeah, it's a really important question as we've been looking at this sector as a whole, and the dynamics related to cement. There are a variety of different ways that we can address that sector as a whole, whether it's addressing the emissions at the source of production, or making these products differently in an innovative way. And I think it's pretty exciting. But ultimately, cement is the ingredient in concrete, right? It's the glue that holds mixtures of small particles or aggregates together to make up concrete, cement, aggregates. So it's cement, aggregates, and water to make concrete, right? And it's really seen as one of the hardest to abate sectors of our economy, because the CO2 is released during the cement calcination process, and that turns limestone into lime and clinker. And so 60% of the emissions from these plants are the quote unquote process emissions. And so it's why what we argue, and why we're spending so much time on it, is it may perhaps be the hardest abate subsector of quote unquote heavy industry as a whole. The other dynamic of the industry that I'll lay out as well is it's very disaggregated, right? It's dispersed. From a business standpoint, it makes sense to produce these type of materials closest to where you're going to use them, right? And so that's what makes it to some extent different from, for example, steel and even chemicals that are a lot easier to be exported.
I'll just add to that. You had asked a question earlier about process emissions. And process emissions are big for cement. More than, I think, 50% of the emissions, CO2 emissions, come direct from the process. So process emissions are a big deal for cement.
Okay, so now let's turn to steel. These are all the things that really fuel all of our infrastructure. And at a 10,000 foot level, how is steel made, and where do those emissions come from?
Well, steel starts at the basic level by mixing carbon and iron together at really high temperatures. So folks are familiar with iron. They see it in rusting vehicles and any other time that oxygen is involved. But as they take steel from its basic components, which is pig iron, which is really raw smelted iron, that contains more carbon than it needs to have for the structural integrity and the performance of steel. So much of that carbon is burned off, and that's where the CO2 comes from in primary steel making, which starts from pig iron. Secondary steel making starts from scrap, and so a good amount of that processing has already been done. And that secondary steel making has typically lower carbon intensity. But the challenge is that there's not enough scrap to go around, so that you can't make all products from scrap. And the performance of some of the materials made from scrap is also not as good as you would like. But there are some exciting developments in the area of steel making to allow it to be made in a lower carbon intensity. There's direct reduction iron, which allows the removal of oxygen from the iron ore without having to melt the iron ore. And that's where hydrogen can come in. So low carbon hydrogen or renewable hydrogen can be used to strip that oxygen out instead of using natural gas or other processes. And that's an advantage where the low carbon hydrogen is available. There's also direct iron electrolysis. So in this case, you're using electrons to do the work for you. And if those electrons come from renewable sources, again, that's a pathway to make lower carbon steel. There also are processes to take the effluent gases. So what that means is to take the stack gases and to repurpose them, to take the CO2 in those stack gases and turn it into useful products like jet fuel or ethanol. And from ethanol, you can make many different chemical compounds. And there's a couple of companies that are working in that space to repurpose the effluent. It's a true example of carbon capture utilization and storage. A key emphasis there being on the U for utilization.
Jeremy, did you have something you wanted to comment on?
No, I think Ed covered it well there.
Okay, so those are some bright spots. Is there any indication of how quickly we can scale those sorts of developments?
There's several different areas for steel. The process heat is probably the starting point. There are additional routes to improve the use of process heat. Reducing the coke rate through the pulverized coal injection is something that could be done today. Quenching to capture the heat can also be done. And there's efforts to improve the conventional blast furnaces. So that all falls under the aspect of energy efficiency. There's also electrification. There's multiple processes in the steel foundry stepping stones, if you will, and some of those can be electrified. The really super high temperature, that's a lot more difficult, but the lower temperature processes can be changed. The direct reduction iron process, there's a company or two that are using those methodologies. Those are in the advanced pilot stage, I would say at this point. Direct reduction iron has been around for some time. There's not as much in the US, but there is in places like Saudi Arabia. So I think a challenge is to bring those technologies to the US and to use them now. That's part of what we'll see with the Inflation Reduction Act, we hope, is demonstrations of those types of technologies here in the US.
The one item I would add there is what's exciting, and to Ed's last point there, is many of these pathways were some of the areas that got this most significant public policy support over the last 5 years, whether it was from the infrastructure bill, the Inflation Reduction Act, or the CHIPS and Science Act, carbon capture. So point source, the tax incentives to incentivize that were significantly increased, and billions of dollars given to the Department of Energy to demonstrate designs, including for cement and steel applications. Hydrogen received significant resources, $8 billion from DOE to develop some hubs in some regions that I think are really prime for steel decarbonization as a whole, as well as a robust investment tax credit and a production tax credit. And then an exciting area that maybe doesn't get as much attention, but to Ed's point about the needing clean heat in this process. I was actually in New York recently for a presentation with the finance community, and high temperature gas reactors, advanced nuclear reactors are working with folks like Nucor, one of our largest producers of steel in the United States, to use the clean heat produced from a high temperature gas reactor like the one under development by X-Energy, which is being supported by the Department of Energy, to get that clean heat. So I think those are exciting. And where there's a gap is the electrification point. There really isn't an incentive in place for innovative new ways to make steel, like a Boston Metal technology, for example, that effectively is doing what Ed was describing in process. And so I think that's something that potentially needs to be addressed in the policy realm. But one thing I think is clear is the global market wants low carbon materials. We're seeing actually our friends, particularly in Europe, moving a little faster on that front, and the demand for lower carbon intensity products. And so I think it's an opportunity for the US to use this policy in place to do public-private partnerships and try to seize that market opportunity, because customers want it.
I want to go back. Sorry, go ahead.
Oh, I was going to follow up on Jeremy's comment there. There is in the U.S. A movement towards preferred procurement of low carbon materials, and you'll see that in the Buy Clean movement. Buy Clean provisions have been supported in California, Washington State, Wisconsin, and others. The administration has put in preferred procurement of low carbon materials for building materials such as cement, steel, and others. So you'll start to see, I think, even greater emphasis on that going forward. But as he mentioned, that's something that can create market pull for those low carbon products, which for the manufacturer perspective, it's important to see that because that allows you to see that there's going to be a market and it's going to be worth the investment to make in these low carbon methodologies.
That's great. I want to pinpoint in on something that Jeremy just said about incentives for electricity. One of the things that we're hearing that may be coming is some sort of permitting reform on the Hill in terms of electrification. And that's something that we've talked about on one of our previous Innovating Out of the Climate Crisis webinars. So if there is a federal action on that, a lot of that action happens at the state level. So what would you like to see happen in the policy realm, either at the federal or state or interstate level, to kind of push that along?
I'll start on that, Jeremy, and you can pick up on that. I think one of the challenges in the current bills is that electrification largely didn't get the push that it probably should have, because along with energy efficiency, electrification is one of the early pillars that can be pushed. It's relatively low capital intensity and cost, and it's something that's really essential for folks to utilize the low carbon electricity from wind and solar. Particularly for industry, it's not what I would call plug and play. You just don't show up with the low carbon electricity and say to industry, well, here it is, boys, go ahead and use it. What needs to happen is that electricity has to be available and reliable 24/7. For that to occur, not only do we need substations and transformers and others to hook up that electricity, but we also need long duration energy storage so that the electrical power can be preserved when the sun doesn't shine or the wind doesn't blow. And that long duration energy storage is an area where the Department of Energy has been working for years. And what's really needed now, particularly at the state level, is to connect that long duration energy storage with the usage of that low carbon electricity with industry. Because industry right now is buying power purchase agreements of renewable electricity, and that's great, helps them meet the sustainability goals, but it's not pushing the needle relative to how they utilize energy. And that's where we need this coupling to occur, connecting the dots, if you will.
I'm really encouraged by the progress in DC on the permitting side, and you make a really important note about the intersection between federal policy, state, and local policy. I think the key is predictability, and into what we were talking about earlier, that this is a critical moment, right? These policies are in place, really targeting deployment over the next 5 to 10 years, the tax incentives in particular over the next decade, right, into the early 2030s. And so what would be the worst thing possible is we get to a point where technology is readily to be commercialized and scale up, and we miss the opportunity to use these tools to deploy them because we're going through unnecessary regulations. And I think that's the key point: unnecessary. No one wants to circumvent environmental laws. No one wants to unduly impact our communities. What's critical is ensuring that it moves along in a reasonable manner, that it's reviewed properly, but ultimately, a red light or green light is given effectively. And I think what's clear from our historical perspective over the last decade is the status quo is not conducive to an energy transformation that is necessary to truly reduce emissions at the speed that we need to, both here and abroad.
Yeah, just to pick up on Jeremy's comments there, I'll note that the amount of transmission lines that are needed to carry that renewable power is really significant. And for us to most utilize the commitments of funding that are in those bills, the BIL plus the IRA, the locations have to be permitted for the wind and the solar, and for the electricity transmission lines that take that power to where it's used. And so, as he also noted, we want to do it in ways that are responsible, but it has to be done relatively quickly as well to utilize that power effectively.
Yeah, concurrently, I mean, if carbon capture, probably an essential piece of the puzzle in many of these industries. We're going to need CO2 pipelines. And if hydrogen is going, clean hydrogen is going to be a low carbon fuel stock, we've got to find ways to better move that around as well. I think that's where things like the hubs concept has come out. The infrastructure bill had a unique financing tool for CO2 pipelines, but this clean energy infrastructure, transmission, CO2 pipelines, hydrogen pipelines, and even gas pipelines in many cases are really going to be essential as we build this out.
Can you tell me a little bit more about that innovative structure?
Yeah, so in the bipartisan infrastructure bill, there was essentially multiple means of doing low cost financing. And so one of the real critical issues with CO2 pipelines, for example, if you're going to truly catalyze projects, is a chicken and the egg problem, right? Projects are going to tell you how much CO2 they plan to capture on a per annum basis, right? And what CO2 would need to be moved into storage sinks. You effectively need to overbuild the pipeline capacity a bit, but you need a customer who's going to pay for that pipeline, right? And so what this gap that it's trying to fill is to ensure that maybe one customer can be the anchor project or common carrier or carrier agreement, but then having some capacity for a common carrier agreement, so that maybe that first project that's moving CO2 from an ethanol plant in Iowa, for example, to the 80 Archer Daniel Midlands storage capacity in Illinois, then allows the steel facility in northern Iowa at some point to connect in, and you don't have to build a whole new pipeline, right? And so it's trying to get at that chicken and the egg problem. I think we're going to have that in a lot of cases. I think the same boat in transmission as well. That's a critical issue. We need long-term planning, and unfortunately, that's project finance isn't necessarily conducive to that long-term planning at times. And so that's where the federal government can come in and provide some incentives or low-cost financing or tools to facilitate that.
Just to build on that, one of the other things that the bill does is it helps to lower, in many cases, what's called as the green premium. That is the extra cost of solutions that are low carbon. For example, with hydrogen, hydrogen is produced now by something called a steam methane reformer, which takes natural gas and takes the hydrogen off of that. And that's used in many industries today, the chemical industry, the refinery industry, and others. But what's being sought in this bill is ways to introduce newer ways to produce low carbon hydrogen through electrolysis. So what they do is they use electricity to generate both hydrogen and oxygen from water. And that clean hydrogen today costs maybe 5 to 7 times the cost of hydrogen from a steam methane reformer. So in the Inflation Reduction Act is something called an investment tax credit and a production tax credit that allows that price difference to be offset for a limited amount of time. And what the government is trying to do then is to not only spur the technology along and lower the cost for producing that low carbon hydrogen, but also establishing a market for that low carbon hydrogen, just as they are also trying to enable the market, as Jeremy mentioned, for CO2 capture, utilization, and storage. So the government's trying to do multiple things with these investments to really spur this transformation.
Yeah, it's one of the important pieces of why all of that federal legislation has come to fruition. It's because it does give that security for companies and organizations to make these kinds of investments. So whether it's research and development or actual execution of these developments in the hard to abate sectors, what kind of timelines are we talking about until we see some of this stuff really come, to our front door and really start to pay off? What sort of timelines and what are the next steps that we need to do, either as private citizens or as a lobbying organization? What do we need to do to make sure that we're still moving the ball forward?
I would say that there's multiple parts of the timeline. For the near term, what can be done is really to push energy and materials efficiency. So the materials efficiency part of that is recycling and reuse, but it's also using those recycled and reused materials as feedstocks, alternative feedstocks that are lower carbon. And there's a number of companies that are working to do that today. The second point that I would make, and some of these are in the Department of Energy's industrial decarbonization roadmap, is electrification. So it's electrifying, Jessica, the relatively low and medium temperature process heat that one could use industrial heat pumps for today, just like the heat pumps some folks have in their homes. These can also be used in industry. And the technology's been developed. It's being deployed in Europe and Australia, South Korea, and it needs to come home to the US. Third, I would say that we could start to push these types of applications in the hubs. As Jeremy mentioned, DOE is supporting these types of technologies in industrial hubs or clusters. Industry tends to be gathered together where there's advantage to resources. And if we can spur this transformation in those industrial hubs, that's something that will seed and carry out through the rest of the nation. And then I think we'll see some of the support for infrastructure build out, such as in the hydrogen pipelines, the CO2 pipelines, the greater transmission and delivery of low carbon electricity, and the generation of that low carbon electricity as well. The things that are associated with infrastructure are just going to take longer, especially as Jeremy mentioned, the permitting angle. But that's something we have to be patient but push for. And in the meantime, we can continue to make reductions in these other methodologies. And connected with that, I'll also note that demonstration of the technologies is really important because it helps us to learn faster. And there's a fair amount of funding from the DOE relative to demonstrations at scale. There are also demonstrations that are smaller, and that's an area where the military can help out because the military can afford to pay a bit more of the green premium, as I mentioned earlier. And the Defense Innovation Unit has also been pushing innovation in that space. So I think there's also really good linkages to what the military could do in this space.
There are some really encouraging signs in the onset that the industry is moving now, though. I mean, we have seen an unprecedented amount of movement of private capital over the last 2 years, a little bit of slowdown in recent months as a result of some tumults in the financial markets with like SVP, for example. But just to give you an example on one technology pathway that we think is really important in this hard to abate sector, carbon capture. In the last 2 calendar years, each year has led to the largest influx of new projects in the project pipeline in 2020 globally, in 2021 and 2022. 150 projects in development as of the start of this year. Almost half of those in North America, with the US policy, which has the largest incentive in the world, representing almost half of those. And so I'm really excited about the opportunities here. And I think, as I mentioned earlier, the rubber is meeting the road here. And I think we're going to start to see some near-term opportunities and projects move forward in the next couple of years.
Yeah, I'll just add to that. I think in addition to what Jeremy said, I've seen a lot of uptick in utilization of the CO2. So I did my first CCUS project back in 2005 when I worked at Dow Chemical in Canada. And at that time, really the only outlet for the CO2 was enhanced oil recovery. Now we see the CO2 being used in cement processes. We see it being used in chemicals. And we see it being used for the generation of fuels as well. There are synfuels projects that take the CO2 that's captured and they combine that with renewable hydrogen to make fuels. And that's interesting as well, especially for hard to abate sectors such as airlines. In the transport there, they've got relatively few options other than biofuels, but we're starting to see a real growth in people looking at ways to utilize the CO2, which I think is important because it helps with the value equation. And as it helps with the value equation, again, it creates more market pull for that product.
One of the more intense permitting conversations happening in DC right now is actually related to secure CO2 storage. the EPA has 60+ applications before it right now. And, the infrastructure bill, for example, gave more money to the EPA to process these, but they're simply not moving at a speed that is necessary for all the projects that are in the pipeline. So you've seen members from both the Republican and the Democratic side, like really urging EPA to speed these things along, because we want different pathways, right? EOR is one option, utilization is one option, secure storage is one option, and really increasing our national capacity for secure storage is going to be essential to meeting the needs of both power sector and industrial applications.
Is the reason for the slowdown capacity issue at EPA? Do they just not have the people to move the process along, or is it jumping through all the bureaucratic hurdles to get it done?
It's a mix of all of those things. They've gotten more resources over the last really 4 calendar years to hire up. With that said, we've gone from basically like 3 or 4 applications to 60+, right? And so I'm sympathetic to that cause. Where I have more concern is some of these applications that are dragging on for 4 or 5+ years, and that's both either project-specific applications or state primacy applications. The Louisiana application, for example, has dragged on multiple years here. I think we're going to see a decision here by the end of the summer, hopefully. But that's one state where the opportunity is immense. So we have huge industrial capacity there. And so CCUS is really going to be essential to doing some near-term carbon reductions there. So I think it's a mix across the board of needing to learn to do these things better, deal with the influx of projects moving forward and be a little more nimble, and attract people who want to be a part of a climate solution, right? And so, I don't know that, engineers in college, the first thing they think is like, oh, I'm going to go work on siting CO2 storage projects, but an essential piece of the puzzle, right? That is just as important as the folks working in the venture capital community or at a tech company, which may seem a little sexier at the upfront, but we need it all.
Great. Thank you for that. That just made me chuckle a little bit. Dr. Ryder, I want to make sure to touch on this. I know we've got about 6 minutes left. So I've got one question I want to get to in the chat, and I'm going to pose one last question because I think it's really important. Dr. Ryder, you were a co-chair in leading the development of something that you touched on a few minutes ago, which is the Department of Energy's Industrial Decarbonization Roadmap. What can you tell us about the establishment of that group, what you've done, and where it's going?
I think one of the things that we've found in that roadmap exercise was the large cross-cutting opportunities, one of which was process heat. Another one would be to transform the energy other than process heat using electrification. So I think both of those were aspects of the decarbonization roadmap, which really need to be pushed, and the Department of Energy is working on both of those. They have a process heat earth shot, as they call it, to improve the cost position as well as the efficiency of process heat. They are also helping to support application of industrial heat pumps in multiple applications. So I think that's front and center. We also looked at the fact that even if you push the 4 pillars of industrial decarbonization, energy efficiency, electrification, low carbon fuels and feedstocks, and CCUS really hard, by 2050, you're still going to have about 13% of the industrial emissions left. So that raises the question, well, what else can you do? And that's where negative emission technologies come in, such as land use and ecosystem preservation, and also direct air capture. But I think to one of the points here, I'll also mention that although we have lots of technologies that we can deploy presently, more than 60% of what we need to reduce emissions by 2050 are still emerging technologies that are not quite at scale in the demonstrations case. So we still need to push innovation and R&D.
Jeremy, did you have?
I was just saying, I couldn't agree more. And it's why also we need to invest more in carbon removal and negative emission technologies. And really would say, appreciate Ed's heads hard work on that DOE report. I think it really gives policymakers a blueprint of why we really need to be investing in these different pathways to drive towards that end goal. And so I think it very comprehensively lays out the case, and I think it played a major role in giving policymakers confidence and putting more incentives and things along those lines in place in those each of those categories that he laid out.
Great, thank you. We've got time for one question, and then I'll give it to you for final comments. This question is from Thomas. Do you see thermal power having the potential to play a major role in reducing carbon emissions?
Yes, I'll start on that. It definitely has a route. We saw that, thermal is the big cross-cutting opportunity. And I think generation of that thermal power by low carbon pathways is really important. So electrification is one. Solar heating might be another. Geothermal, I think, is also part of that story. Jeremy mentioned nuclear, and small modular nuclear is something that some companies have been turning to. It kind of depends on your geography, where you are, and how that fits with the resources that are available locally. Not everyone's going to have a really good geothermal source in their backyard, but they may have applications where they can take heat and they can utilize it more efficiently. For example, in Europe, they use district heating. So they take waste heat from industry and they use it to heat homes and businesses and others in the area. And they also return things relative to cooling. So I think there are things that we can do in the US that allow us to tap into efficiency in a much broader sense than what we're doing.
Great, thank you. Well, believe it or not, we are already out of time. So I guess we're just going to have to do this again. I will pose one final question for your thoughts. This is hard. It's right there in the name, hard to abate. It's going to be hard work, and we need the best and brightest to collaborate to get to yes on this and to get where we need to be. So what can you offer to those who are just looking at this and thinking, this is just an intractable problem?
I would say that there are opportunities in this space, and we've talked about those in several areas. And what we need are folks to join the workforce to address these challenges. This is a transformational moment. This is the time that's actually exciting to be in industry because of the needed transformations. So innovation is going to be at the heart of this. And I think we really need people to look across not only the current disciplines, but across multiple disciplines. And it's that kind of intersectional learning that's really exciting.
I couldn't agree more that this is the moment. This next decade is really exciting to be in this space. And what gives me the most optimism here is there's a lot of good reasons to do this. Climate is a big one, but also how do we increase American competitiveness? How do we increase domestic supply chains and lead to real job growth in heavy industry and in manufacturing and jobs of the future? It's a really exciting time for folks to get into this sector, and I think it's an area where I have a really high optimism, even though as you state, it's a hard nut to crack, and there's a lot of exciting different ways that people can get involved.
Well, gentlemen, thank you so much for taking the time today. Thank you, everybody who joined us. I'm sorry if I couldn't get to your questions in the chat, but hopefully we'll be able to do this again soon, and we'll be able to celebrate the victories that we've had. And that's a great way to end on an optimistic note. So thanks for being with us, and we hope to see you all again soon.
Thank you.
Thanks, Jessica.